In today's tutorial, we are going to talk about how to convert the units of the area of objects from one to another. In our previous tutorial on how to convert the units of length of objects, we laid the foundation for today's tutorial. I would therefore suggest strongly that you watch the previous tutorial before this one, because I'll be making a lot of references to that one. The link of that tutorial is in both the description and comments sections. Now let us move right into today's lesson. We are talking about how to convert the unit of the area of an object from one to another. And like we did in the first tutorial, we are going to use two mathematical concepts, the concept of indices and the concept of prefixes, in our tutorial. Although there are several methods that we can use, the simplest and the most convenient one that do not need memorization is the use of indices and prefixes. And so with indices, we are going to need only these two laws or properties, the law of multiplication and the law of multiplying a power by an exponent. And since we have gone through this already, let us go to the prefixes. For the prefixes also, we are going to need all the four that we used under the first tutorial. That is the deci, the centi, the milli, and the kilo. And as you can remember, the deci has a value of 10 minus 1. That is 10 exponent minus 1. The centi has a value of 10 exponent minus 2. The milli has a value of 10 exponent minus 3. And the kilo has a value of 10 exponent positive 3. Now let's talk about the unit of area. When you measure the area of an object, what unit are you going to assign to it? The SI unit, the universally agreed unit assigned to area of object, is the squared meter. But apart from the squared meter, there are other units that we can write our answers in. And that is why it becomes very necessary to know how to convert from one to another. Apart from the squared meter, we can also write the units of the area of an object in squared decimeter, in squared millimeter, in squared centimeter, and in squared kilometer. Now let's talk about these two concepts that I have fabricated to help my students really do this conversion without much stress. These two concepts, as we can remember, are the concept of substitution and the concept of introduction. There is an additional detail on how to do substitution and introduction when it comes to area, and I want you to take note of that very carefully and differentiate between how to do substitution and introduction when it comes to length and area. So let's start with substitution. Assuming we have 2 centimeter squared and we want to change it to meter squared, we know already that we have to substitute the value of the centi so that we can have our answer in meter squared. But what we have to take note of is that because we are dealing with squared meter, we have to also square the prefix. Let me take it again. Because we are dealing with the unit of area, which is squared, whenever we substitute the value of a prefix, we have to square it. And this is the additional detail I want you to take good notice of. And so 2 centimeters squared, converting it to meter squared, we are going to get 2 times 10 exponent minus 2 meter squared. And you understand that the value of centi is 10 exponent minus 2. And because we are dealing with area, we have to square the value. And so applying indices here, we are going to get 2 times 10 exponent minus 4 squared meters. And by this, we have converted from 2 centimeters squared to meter squared. Now let's look at how we do introduction here also. Let's take the 2 times 10 exponent minus 4 squared meter that we had under the substitution, and let's convert it back to centimeter squared. Once again, you would realize that we don't have the centi in this figure given, but we want to introduce it into our final answer. And so when you are introducing a prefix, the sign of the prefix must change. In addition to that, because we are dealing with the squared of the units, we also have to square the prefix. In this case, we are going to have the 2 times 10 exponent minus 4. And now introducing our prefix, which is the centi, we are going to have times 10 exponent 2 squared. And this gives our answer in centimeter squared. Remember that when we are introducing the centi, the sign of the exponent will change, so that although the centi is originally exponent minus 2, it will now become exponent positive 2, and all of it will be squared because we are dealing with area. Now let's apply the concept of indices here to finally get to our answer. So we are going to get 2 times 10 exponent minus 4 times 10 exponent positive 4, and our answer is still in cm squared. Now finally applying indices here, what we are going to get is 2 centimeter squared, because 10 exponent minus 4 times 10 exponent 4 is going to give us 1, and so 2 times 1 is going to give us 2. And this is how we do introduction when we come to converting the unit of area from one to another. Having understood this, now let us go to our first question for the day. Our first question is asking us to convert 100 meter squared to decimeter squared, centimeter squared, millimeter squared, and kilometer squared. If you have watched the previous video, it's going to be very simple for us to go through this. Now let's take the first one, 100 meter squared to decimeter squared. So here we are supposed to do introduction, because in the original figure given to us, which is the 100 meter squared, we don't have the deci in it. We have to introduce the deci into our answer. And so what we are going to get is that we are going to get 100 times 10 exponent 1, all exponent 2, because the deci is minus 1. But since we are introducing it, it's going to be positive 1. And because we are dealing with area, we are going to square the prefix. And this gives our answer in decimeter squared. So applying indices, we are going to get indices, we are going to get our answer to be 10,000 decimeter squared. Let us convert this one into standard form. We are going to get 1.0 times 10 exponent 4 in decimeter squared. The second one, we are supposed to convert 100 meter squared to centimeter squared. Once again, we have to introduce the centi in our answer. And so we are going to get 100 times 10 exponent 2, all exponent 2. And this gives our answer in centimeter squared. By so doing, we have just introduced the centi and squared it because we are dealing with area. Once again, applying the concept of indices and finding our final answer, we are going to get 1 million centimeter squared. And changing this one to standard form, we are going to get 1.0 times 10 exponent 6 centimeter squared. The third one, we are supposed to convert 100 meter squared to millimeter squared. Once again, we are substituting the value of milli and squaring it into our final answer. So we are going to get 100 times 10 exponent 3, all exponent 2. and this converts our answer to millimeter squared. Now let's apply indices here to find our final answer. We are going to get 100 times 10 exponent 6 millimeter squared, and converting this to standard form, we are going to get 1.0 times 10 exponent 8 millimeter squared. The fourth one, we are supposed to convert 100 meter squared to kilometer squared. Once again, we are going to introduce the kilo into our final answer. So we are going to get 100 times 10 exponent negative 3 squared, and this moves our answer into kilometer squared. Let us remember that the kilo originally is positive 3, and so when introducing it, the sign must change. That is why we have the minus 3 here. Let's apply indices here. We are going to get 100 times 10 exponent minus 6 kilometer squared, and changing it to standard form, we are going to get 1.0 times 10 exponent minus 4 kilometer squared. So that is our first question. Let's go to our second question. Our second question is asking us to convert 20 decimeter squared to meter squared, centimeter squared, millimeter squared, and kilometer squared. Alright, so the first question, 20 decimeter squared to meter squared. So here you would realize that we are just to do substitution. We are to substitute the value of the deci into our final answer. And so we are going to get 20 times 10 exponent minus 1, all exponent 2. And this converts our answer to meter squared. Applying indices, we are going to get our final answer to be 0.2 meter squared. The second is asking us to convert 20 decimeter squared to centimeter squared. So here we are going to do two things. We are going to first of all convert to meter squared and then convert to centimeter squared. So like we said in our previous video, changing 20 decimeter squared to centimeter squared basically means that you are supposed to remove the deci and replace it with a centi, so that we are going to get our final answer in centimeter squared. So how do we remove the deci? You remove the deci by replacing or substituting it with its original value. So you are going to get 20 times 10 exponent minus 1. Then we square it because we are dealing with area. Now let us convert to centimeter squared by introducing our centi. So by introducing our centi, we are going to get 20 times 10 exponent minus 1 exponent 2 times 10 exponent 2 also squared, and this converts our answer to centimeter squared. Now let's apply indices here to get our final answer. We are going to get 2000 centimeters squared as our final answer if you do the indices. The third one is that we are supposed to convert 20 decimeters squared to millimeter squared. So once again, we are supposed to take the deci from there and replace it with the milli, so that our answer can be in millimeter squared. So let us first of all substitute the value for the deci into our answer and see. We are going to get 20 times 10 exponent minus 1 squared. So now let's introduce our milli. We are going to get 20 times 10 exponent minus 1 squared times 10 exponent 3 squared, and this converts our answer to millimeter squared. Now let's apply the law of indices here. We are going to get 20 times 10 exponent minus 2 times 10 exponent positive 6 in millimeter squared. Now still let us apply indices here to get our final answer. We are going to get 20 times 10 exponent positive 4 millimeter squared. And since this is not in standard form, we can finally write our answer in standard form as 2.0 times 10 exponent positive 5 millimeter squared. Now the fourth one, we are supposed to convert 20 decimeter squared to kilometer squared. As at this time, I know you can easily do that. So let's go through very quickly. We are going to get 20 times 10 exponent minus 1 squared times 10 exponent minus 3 squared, and this converts our answer to kilometer squared. Applying indices, we are going to get 20 times 10 exponent minus 2 times 10 exponent minus 6. Then applying indices again, we are going to have 20 times 10 exponent minus 8. And so our final answer, which is in standard form, is going to give us 2.0 times 10 exponent minus 7 kilometer squared. Now our third and final question for this tutorial, we are supposed to convert 5.4 centimeter squared to meter squared, decimeter squared, millimeter squared, and kilometer squared. So let's take the first one, 5.4 centimeter squared to meter squared. Here you would realize that we have to do substitution. We have to substitute the value of the centi, and that one will convert our answer into meter squared very easily. So let's go. 5.4 times 10 exponent minus 2 squared, and this converts our answer into meter squared. Applying indices, we are going to get 5.4 times 10 exponent minus 4 meter squared. And since in physics it is more appropriate to leave our answer in standard form, this is what we are going to get for our answer. Now the second for us is to convert 5.4 centimeter squared to decimeter squared. So here you notice that we are supposed to first of all convert to meter squared before we can get our answer in decimeter squared. So let us substitute the value of the centi and let's see what we are going to get. We are going to get 5.4 times 10 exponent minus 2 squared times 10 exponent 1 squared, and this converts our answer to decimeter squared. So it means that by substituting the value for the centi, we are going to get 10 exponent minus 2 squared, and by introducing the deci, we are going to have 10 exponent 1 squared. So let's apply indices here and see what we are going to get. We are going to get 5.4 times 10 exponent minus 4 times 10 exponent positive 2, still in decimeter squared. Applying indices finally and getting our final answer, we are going to get 5.4 times 10 exponent minus 2 decimeter squared. The third one, 5.4 centimeter squared to millimeter squared. Let's first of all substitute the centi and then convert to millimeter squared. So we're going to get 5.4 times 10 exponent minus 2 squared. That is by substituting the centi. Now let us move on and then introduce our milli. We are going to get 5.4 times 10 exponent minus 4 times 10 exponent 3 squared, and this converts our answer into millimeter squared. So now let's do the indices. We are going to get 5.4 times 10 exponent minus 4 times 10 exponent 6 in millimeter squared. Let's do the indices again and complete our answer. We are going to get 540 millimeter squared. This is a very small number, and so we can leave our answer like that, 540 millimeter squared. The fourth and the final one, 5.4 centimeter squared to kilometer squared. So let's first of all substitute the centi and then later introduce the kilo. we are going to have 5.4 times 10 exponents minus 2 squared. And this gives our answer in meter squared. Now let us introduce the kilo and see what we are going to get. 5.4 times 10 exponents minus 4 times 10 exponents minus 3 squared. And this converts our answer to kilometer squared. Let's do the indices. 5.4 times 10 exponent minus 4 times 10 exponent minus 6 in kilometer squared. Applying indices again, we are going to get 5.4 times 10 exponent minus 10 kilometer squared. And since this is already in standard form, we can leave our answer like this. So this brings us to the end of today's tutorial on how to convert the unit of the area of objects from one to another. Like always, I would want to leave you with 2 questions for your own practice. You can solve them and share your answer with us in the comment section.